Hi everyone, Victor here again, and in today's lesson, we're going to be doing something very interesting, which is we're going to be looking at how to deploy a self-managed Kubernetes cluster on Ubuntu Linux. And this lesson is going to be divided into two parts. Part one is going to be the manual deployment of the Kubernetes cluster, and the second part is the part where we're going to be automating this deployment. So for the automated part, we're going to be using Terraform to deploy the virtual machines, and we're going to be using Ansible to deploy the Kubernetes cluster. And for the deployment topology, we're going to be using one load balancer, which is going to be the HA proxy. We're also going to be using two master nodes and two worker nodes. So meaning that we're going to need a minimum of 5 virtual machines. And these same steps can be applied to tens or hundreds of nodes. So this is the architecture, right? So the load balancer is going to be placed in front of the two master nodes, meaning that for you to be able to communicate with the API server, you would need to come in through the load balancer. And these are the IP addresses of the 5 nodes, and we're going to be using the Ubuntu Linux for the virtual machines. And also one important thing you need to know about is the port. So there are various ports that needs to be opened. So for the load balancer server, you need to open port 6443 for the Kubernetes API and 8404, which is optional. And for all the Kubernetes nodes, for both masters and worker nodes, you need to open port 6443, 10250, 3000 to 32767. And for master nodes only, you need to open port 2379 to 2380, 10257 and 10259. And the reasons why you need to open those ports are here. So I'm going to be dropping the link to this particular lesson in the description box below, so you can go through it if you need any information. This is production spec, right? And like I mentioned, this can also be applied to tens or hundreds of nodes. So without further ado, let's get started with the demo. Okay, so the first thing we're going to do is to configure the load balancer, which is the HA proxy service, and this is the load balancer server. And to do that, I'm just going to say sudo apt install HA proxy. So I'm going to say yes. Now that this is installed, we need to edit the HA proxy configuration file. So I'm just going to do sudo vi. It's in etc HA proxy.cfg. So at the end of this line, I'm going to append things here. So what I'm going to do is I will just go directly to the website and copy the things that are going to be appended here. So I can paste them here. So what I'm saying here on this file is that the port for the Kubernetes API, which is 6443, is going to be the front end with the IP address of the load balancer, which is 10.10.4.145. And then for the Kubernetes master nodes, the two master nodes, that's going to be the back end. And these are the IPs. And this is also the port. So this file is self-explanatory. And then I can save this file. Then I can restart the HA proxy service. So I can just say sudo systemctl restart HA proxy. So I can then, okay, so it's trying to get those services, and apparently we don't have any service that is listening on port 6443 at the moment, so no server is going to be available. This is correct, so I'm just going to do Ctrl+C to cancel this. The next thing I'm going to do is to open the important ports we mentioned. So I'm just going to open port 8404 TCP. Now, then I'm also going to open port 6443 TCP. Okay, so I believe that now we have the HA proxy configured, and if you want to confirm that, you can do status. Alright, so you can see that the service is active and running, and it is also ready. So the reasons why, like I mentioned, the reasons why this are down, both master nodes, is because at the moment we've not configured Kubernetes, and port 6443 is not listening on these nodes at the moment. So now that we're done with the HA proxy configuration, the next thing we want to do is to configure the Kubernetes cluster. So I'm going to start by configuring master node 1. And again, it depends on how you want to go about it. Like for my own environment, what I'm going to do is I'm going to configure the one node, and when I get to a particular point, I'm going to shut down that node and create a template for other Kubernetes node from that same node, right? And if your own environment, if you cannot create a template, then you would need to run the commands on all the nodes at once. So now this is the master node 1. What I'm going to do first is to open the necessary ports we mentioned. So I'm just going to say allow port 2379 to port 2380 in TCP. Then I'm also going to allow port 10257. I'm also going to allow port 10259. I'm also going to allow port 6443, which is very, very important. 6443. Then I'm also going to allow port 10250. And I'm going to allow port 3000. That's 3000 all the way down to 32767. Yeah, 32767. Okay, so now that we have the necessary ports being allowed, the first thing we need to do is to disable swap. And the reason why you need to disable swap is because it's not to cause inconsistent memory handling, right? So this is essential, especially for if you want ports to be stable, and if you don't want performance issues, you need to disable swap when configuring Kubernetes. And to do that, I can just say sudo swap off -a, and now I can comment off that line from the etc fstab file, so that by the time you reboot your system, it's not persistent. And just because I'm not going to be using the VI editor, this command will help me to do that. And now I can confirm if swap is freely disabled. or it's completely disabled. If I do free-h, you can see that swap is completely disabled. So that's the first step. And the second step is to ensure that the necessary kernel modules are loaded at boot time for Kubernetes. And let me show you that here. Like I've mentioned, I'll be dropping the link to this particular website in the description box below. You can follow through. It's a there are very simple steps. Step 2, we have step 3, we have all the way down to I think step 14, right? So they are very simple steps, and all you can do is to just copy the commands straight away from the website and slam it on your machine too as well. So the necessary modules that we're going to load at boot time at the overlay module and the br-filter module. And to do that, I'm just going to use these commands to load the modules. And the reason why you need to load the modules I also mentioned, right, in that same article. And the reason is because for the overlay module, that is used for the overlay file systems, which are critical for container runtimes like Docker and Containerd. And for the BRNet filter module, that is essential for packet filtering and network bridging in Kubernetes. And that is why you need to enable those modules or load those modules at boot time, right? So now that we've done that, I'm going to increase this a bit. I'm going to adjust this a bit. Okay, so now that that has been done, we need to verify that the content is present, and I can just do cart. Let me adjust this a bit again. Right, so I can do cart etc modules as load.d, then kts conf. So now I can confirm that the content is present, and now the next thing I need to do is to load the modules. And to do that, I can just do sudo mode probe overlay, and then I can also do sudo mode probe br_net filter and I can also verify that the modules are loaded by just in ls mode. I can grep for overlay, and I can also grep for the brnet filter. All right, now that we're done with step 2, the third step is to ensure that IP forwarding is enabled at the kernel level, and this is also critical for pod communication and cluster routing. This configuration is also essential for Kubernetes networking, and to do that, I'm going to use the command right from the website. I'm going to copy it and paste it here. I'll just clear the screen. So I'm just going to paste this here. And now the next thing I'm going to do is to apply the configuration immediately without rebooting. So that this would reload the sysconfig files and etc cctl.d. So I'll just say sudo cctl --system. Alright, so this is fine. This is what I'm actually looking for, which is the IPv4 forward, which is equals 1. And sometimes if you have a lot of values in your screen, you can just simply verify by doing sudo sysctl or sysctl net, which is this. I'm just going to copy this and paste it here. We can already see the value here, but I'm just showing it to you in case you have a lot of files all over your screen. And yeah, so you can see that the value equals 1. So this is the important value we are actually after. So the next step, which is the fourth step, is to install the prerequisite packages, especially for step 5. And what are these prerequisite packages? Right, these are the packages that we would need to install the container runtime. And so I'm just going to go to the website and copy these packages for installation. So I'll just copy this and paste it here, and I'll allow this to install. Alright, I'm having issues with my apt. Just going to kill this process. 2117, and I'm going to remove this logs, and I'm going to reconfigure dpkg. Alright, so this should fix the issue I'm having. Let's try and install these packages again. So this is done, and for the step 5, we're going to install the container runtime, which is container D. You can either install Docker, of course, which also comes with container D, or you can just install container D straight away. So for me, for this setup, I'm going to be installing container D straight away. And before I do that, I also have, so the packages we previously installed, you can look at those packages and the reasons why we had to install the packages here, right? So I'm going to copy this command to install container D runtime. So for some reasons, I have issues with downloading some files, especially from the Microsoft's website or anything that has to do with Microsoft. And since GitHub has to do with the Microsoft, you can see that this is going to take a longer time. Imagine I want to download a file of approximately 46 MB, and I have about 55 minutes left. And before you know it, it will still go back to about 1 hour. So what I'm going to do to help myself, I've noticed this in my environment. So what I'm just going to do to help myself is to download it somewhere else and then copy it into this server, which I'm just going to do. So I'm going to cancel this, and if I do ls, I'm just going to delete this guy here, because really, if you look at it, you will see that I'm just going to be here forever, you see. So I'm going to delete this guy, and then yes, I'm going to move the one I copied here into this folder. I mean the one I downloaded on another system into this folder. I think I'm disconnected from this machine. Let me try and fix why that is. I think while I was trying to copy the file, I somehow got disconnected. I'm going to clear my screen. I'm going to confirm that I now have the file being copied. So the next thing to do is to extract the downloaded file to the user local directory, and I'm just going to copy that from the website and paste the command here. And now that this has been done, I have to run the container D as a systemctl service. So I'm just going to go to the website too as well. Copy the command to do that. And then paste it here. Okay, and the next thing to do is to create a directory and move the downloaded service file to that directory. So again, I go to the website, just copy this, paste this here, and I can now move. So I just copy this, paste this here, and I can create the second directory. So all this process, like I've mentioned, is the fact that we're trying to make container D run as a systemctl service. So I can create a second directory. I think I'll just type this, and the next thing to do is to generate the default config for container D and save it in this directory. So I'll just copy this down. So I do sudo make directory parent and /etc container D. Then I can paste what I just copied. And the next thing to do is to change the system cgroup parameter from false to true. And the reason why you're doing that is because Kubernetes expects to manage cgroups using system D as the cgroup driver, especially on modern Linux. So you need to change that parameter. So I'm just going to copy this and go back to the command line. Just paste this here. And the next thing we can do is to reload the systemctl daemon. So I can just do sudo systemctl daemon reload. And then I can enable and make the settings persistent. So I can just do sudo systemctl enable now container D. Okay, so now I can verify that the container D service is up and running. So I can just do systemctl status container D. So now you can see that container D is up and running. So the next thing, the step 6 is to install runc. That is a low-level container runtime. So for me to do that, I can copy this command to download the runc. But another issue, like I mentioned, is that this is going to take my time, right? So I'm just going to, I've downloaded it somewhere before, so I'm just going to copy and paste this. Or I'm going to transfer it to this system. So copy and paste this. It's going to waste my time. Right, so the best bet is for me to just, copy to this system. So if I do ls, alright, so it's copied here now, and I can now install runc. So I can do sudo install 755 runc in user local sbin runc. So the next thing to do is to configure CRICTL to work with container D. And of course, you need the CRI/CTL for you to be able to interact with container D. So I'm just going to copy the command to as well. Let's copy this. I'm going to paste this here. We cannot find CRI/CTL. Let's confirm the size of the run C that was moved. 11 MB. This has been installed. So why can't we find CRI/CTL? Okay, so what we're going to do is to install CRI/CTL then, since it can't be found. For some reasons, I don't know why this cannot be found. I've done the steps, right? I don't usually have reasons to install CRI/CTL, but now that we are having this issue, it's just part of troubleshooting steps. So let's just install CRI/CTL. And again, we're back to this connection issue. So I think I'll just have to wait till this is installed because I don't have this package anywhere. Or what I can do again is to install it somewhere and then, copy it in the system, or we can just wait it out. So this is taking time, and I believe I must have missed a step. Let's confirm that. I believe I must have missed a step here. So this is step 6, step 5. Step 5, we downloaded the binaries, which was this. We extracted it. We didn't download the container D as a systemctl service. So I think this was where the issue is, and that's why we cannot find CRI/CTL. Just gonna clear the screen here. So now I can run the command. We're still having the same issue. Okay, I'll just run this instead. So I can't wait. I have cancelled it and I've downloaded it and copied it in here. And now this is it. So let me just look at the size for this one. So it should be 24 MB. So the former one that was being downloaded was around 3.6 MB. So we're just going to use this one. So I'm going to extract these two as well. And I'm going to move to user local bin, and I can say CRI/CTL -- version. So now we have the CRI/CTL tool installed here. Now I can copy this command again and paste it. Alright, so this has worked. And the next step, which is step 8, is to install the Kubernetes packages or Kubernetes tools, which are the kubeadm, kubelet, and the kubectl. So I'm just going to go to the website and copy that command too as well. So before we're able to install these packages using the apt package manager, we need to install the necessary packages for that to work, and also the repository. So I'm just going to copy this, paste this here, copy this as well, paste this here. So you can run sudo apt update, but I'm not going to do that, right? But you can do that. So I'm just going to install these 3 packages. Just going to kill this. um 54504 this here. So for some reason my apps get locked, so I'm going to try and install these packages again. Maybe I'm just going to have to run the apt update. There's an issue with the my apt. It is held by a process 6010. Damage my load. Let's see. So now I can install these packages. Again, I'm having the same issue. I'm having the same issue. 6360. So I think I will need to figure why I'm having this problem. I need to figure that out. But I believe you won't have this issue I have on the system. So I just need to troubleshoot this before I can move forward. So now the packages are being downloaded. The next step is to prevent automatic upgrades of this component, because whenever you do apt updates on your system, you don't want these three components to be upgraded. And that's because whenever you're upgrading Kubernetes components, you do them sequentially, and it's something that you need to plan for. So we're going to hold these packages, and I'm going to run the command sudo apt mark hold kubectl kubeadm and kubelet. Alright, now that we've set these guys on hold, the next step is to initialize this master node as a master node or as a control plane, right? So we're going to initialize this node as a control plane or a master node. And before we do that, we can, verify the versions of the packages that we've installed. So I can just do kubeadm version. You can see that I'm running version 1.29, and for kubectl I can do kubectl version, and it's the same version. And for kubectl for kubelet I can do kubelet. Sorry, we're gonna have to do kubectl version, kubeadm version, then kubectl version client. That should be client here. Alright, so now that we verified the versions, what I'm going to do is to shut down the system and then create a template for other nodes using the system. So what I did was I did not install this command on the three other nodes, right? From our architecture, we have two master nodes and we have two worker nodes. So I can just power this off or do shutdown. Alright, then I'm going to go to my vCenter. So here's the master node 1, and this is the load balancer that we installed. So I'm just going to create a template from this one. So I can say clone to, yeah, I can actually clone to a virtual machine as well. So let me just go into virtual machine and do master node 2. Then I can do next, put it somewhere here. Can put it somewhere here. Do next. Put it on a data store that I want to put it in, and I do next. Do next, and I do next. So this is going to create another node, which is master node 2. When this is done, I will create another one called master node 3 till we create worker node 1 and worker node 2. So we'll just create them from the same template. So I'll create another one. I'll clone to a virtual machine and say worker node 1. Just going to do next. Gonna do next here. Gonna pick a data store. Trying to look for the right data store. I usually pick. Do next. Do next and do finish. So I'll wait for this one to also get created. It's completed. So I think I can just move it here. Worker node 1. Just move it here in this resource pool. And then I'm going to create the last worker node. So I can clone this again and say clone to virtual machine and do worker node 02. Next, I can even pick the resource pool. Do next, pick the data store. Do next, and do finish. So I think I need to rename this as this wasn't properly spelled for the master node 2, so I can just say master node 02. Alright, now so you see that I have 4 virtual machines now. I have master node 01, master node 02, worker node 01, and worker node 02. So if you're in an environment that you cannot clone to virtual machines or clone a template, you wouldn't have any other choice than to install your 4 Kubernetes nodes, and then the commands that we've initially run, you have to run it on those nodes individually. But because I want to save time for myself, that was why I had to, clone it this way. Alright, so the master node 1 is back up, and I've done every editing I need to do. So you can see that this is 10, 10, 14, 120. And for master node 2, this is the master node 2. And if I do IP here, you can see that this is 121. And for worker node 1, so this is worker node 1. If I do IPA, this is 122. So I've done all the renaming of the host name and the IP address. And for worker node 2, where is that? So if I bring up this worker node 2 and if I do IP-A, you can see that this is 123. Alright, so now that we have all the Kubernetes nodes ready, we're going to continue with our steps, and right on the first master node, we're going to initialize this node as the control plane. So after step 8, which is what we've done, and here. All right, so that was why I wrote it here, that at this point, if you're going to be using a template to create other Kubernetes nodes, which we just did, you need to shut down the server and create a template from it. So on step 9, this is going to be done on the master node 1, and then you need to initialize this node as the control plane. And to do that, we're going to use this command, right? And that's because we're using a load balancer. If you're not using a load balancer, you might need to have different flag. But here we're saying that sudo keep adm initialize this node as the control plane, right? And this is the network CIDR. This is for the ports inside the Kubernetes cluster. And because I'm going to be using Calico, I'm going to be using the default network for Calico. If you don't want to use the default network, if you want to use a different subnet for your port network, you also need to edit the Calico configuration file. And the endpoint is my load balancer, right, which is the 10.10.41.45, which we have configured at the beginning of this lesson. So I'm just going to copy this command and I'm going to paste it here and do enter. So this is going to take a bit of time because it's going to fetch, it's going to pull the image, the container image, and coupled with the fact that my network is even slow, my internet is slow, this will take a bit of time. So you can see that it's pulling the image from this registry. So I'm just going to pause this video, and when this is being initialized, I'm going to continue with the video. And just before I pause the video, I just want to show you that you see that when we run this command, all the settings for Kubernetes that we had to do, you will see that there are validations for them, because if you don't do it, this command is going to fail, right? It's going to fail. So you can see here that it's saying running checks, validating the content file here in this sysnet directory, which we had to configure. So I'm looking for where it started validating if swap is disabled or not, right? So because I had to compress my screen so it can be visible, I might not be able to show you that, but I can tell you that when you're running yours, just read all through the pre-flight checks, that's the validation. You will see that everything we disabled were being validated. So now we can see that this is done, and you can see that this has been initialized as the control plane. And I'm going to scroll up so you can see that your Kubernetes control plane has initialized successfully. And to start using your cluster, you need to run the following as a regular user. Alternatively, if you're a root user, you need to run this command. Because I'm not the root user and a regular user, I'm going to run this command, right? And I'm going to paste it here. And also, before I press enter, you can see here it's saying that you can now join any number of control plane, any number of the control plane node running the following command on each as root. So that means on every control plane or on every node that we want to make master nodes, we can use this command to join those nodes to the cluster. And here, for every node that we want to make worker nodes, we can use this command. So let me just do enter. All right, so if I do kubectl, get nodes, so you can see that we have one node now, and it is in a not ready state, and that's because we don't have any network plugin installed yet. And that's why when I do kubectl get ports -a you would see that every other pods are running, right? Inclusive of the API server. You see that this is running, but for the network ports, which has to do with the core DNS, you can see that they are in a pending state and they are not running yet. And that's because we haven't installed the network CNI. And in this lesson, we're going to be using the Calico CNI plugin, right? And that's why if I also do, let's look at CRICTL ps-a. You can do sudo bang bang. So here you can see all the containers that are running too as well. So for us to install the CNI plugin, I'm going to also go to the website and copy the commands here. And before that, I'll just copy this one and paste it and keep it in my notepad, right? So I'm gonna copy this and keep it in my notepad so that I can use this for the other nodes, right? So I'm just gonna paste this here and keep it here in my notepad. I'll also copy the one for the worker nodes and paste it on my notepad. So I'll just keep it here. And again, if you want to know more about the Calico, you can also read stuff about it here on the website. So the first thing to install the Calico CNI plugin is to install the Tiger operator controller. And to do that, I'm just going to copy this command. Wow, this might also take some time. And there is something you need to understand about Tiger, the Calico. Okay, all right, this is good. This is a bit fast. So I need to quickly explain something here so that whenever we're working on the next lesson, that's automating this process using Ansible, you can understand what is happening here. So I had a bit of challenges here until I had to figure it out with my playbook. So if you're using the command line to install this operator, is very straightforward. You don't have any issues with it. But if you're using Ansible, what you should know is that this operator pod, right, consists of the CRDs which has been installed and the operator pod itself. And a very important CRD here is the installation CRD, which is this one. So this installation CRD has to be established with the Kubernetes API first before you can now apply this second command, which is the YAML manifest file, right? If it is not established with it and you apply this second command I'm about to run here, if you're using Ansible, you're going to be running into a lot of problems. Trust me, I had to figure that out. It took me hours, but I'm going to be explaining better. I'll explain that more in the next lesson when we're doing the automation part. So now I would install the Calico networking configuration manifest file. So I'll just copy this, paste it here. And before I do that, you should know that, like I said, that this operator has its own pod. Let's even see if the pod or if the Tigera pod, if the operator pod is running. So I can just do kubectl get pods all in all namespaces. You can see that the Tigera pod is not running, which is this here. So it has to come up. And again, before it even came up, the installation CRD has already been established with the Kubernetes API. So I'm going to run the second command, which is to apply this YAML manifest file. Again, this is going to take a bit of time because it's trying to download from GitHub. And so far, so good. This is nice because with what I'm seeing, this is done. I just hope it downloads the right file. Okay, now that this is done, I can now apply the YAML manifest file. Let's see what has been downloaded. That's custom. Let me look at the size of this file. 4.0 kilobyte. I doubt it if this file was actually downloaded in full. Shouldn't be 4.0 kilobyte. Well, let's apply. I don't know. Let's see. Let's apply. If it doesn't work, I'm going to have to download it somewhere else and okay. Apparently I think it worked, and if I do kubectl get ports, so you can now see that the other Calico components are being created. You can see this and they are being created in a Calico namespace. So you can see that this pod is trying to get created. So it is until when these pods are fully created, that is when the core DNS pods will start running well. And you can see that they are still in the pending state. So let's wait. This takes about 3 to 5 minutes before the pod starts coming up. So let's wait and see what happens. Okay, so let's check again. Alright, so 2 of those pods are running. This is still creating, and 1 core DNS pod is running. So let's all wait for this to finish its creation. So let's check again. Alright, so you can now see that all pods are running. The core DNS ports are up now because every Calico component to are up, and then our node that is in a non-ready state should now be in a ready state. So let's do kubectl get nodes. So you can see that master node 1 is now in a ready state, and now this we're done with the initialization. The next thing to do, or the next steps, is to start adding other nodes into this Kubernetes cluster. So the other node that we're going to add is the master node 2, right? So I'm just going to bring that up. So I'm going to copy the command I pasted in my notepad to join the second control plane, and then I'm going to add this command here and press enter. So I'm saying that I'm not running this as root, so I can just add sudo to the command. So just say sudo bang bang, or just do this same thing. So it's also going to run the pre-flight checks and download those images the same way it was being downloaded on master node 1. So it's going to take a bit of time, right? And when this is done, I'm going to continue with the video, so I'll just pause it for now. Alright, so I have waited for like 3 hours for you to know how terrible my internet is, and at the end of the day I was getting an error, and that's because you can see here that it's saying that the downloading the certificate in secret, blah blah blah, set was not found. The secret might have expired, and that's because it expires after 2 hours. You initialize the master node, the first master node, and because it's expired and this has been trying to pull the images for over 2 hours now, and that's why I'm running into this problem. So I'll need to regenerate this. So I'll just say sudo. You can see the stress that I'm going through. So please subscribe to this channel, share, like if you get to this stage of the video. Okay, what are we seeing here? Remote version is new, falling back, error, cannot bootstrap. Oh, okay, I need to do that from the master node 1. I need to run this command from master node 1. So I'll just bring up master node 1. Okay, I'll just run this from master node 1. Right, I need to add sudo to the command. So what I'm going to do for both worker nodes is that, so this is the certificate. What I'm going to do is that I'm going to package the already downloaded images in this master node 1, and I'll just go and dump them in worker nodes. You don't have to do that, of course. I believe you're gonna have good internet. You're not staying where I'm staying. I'm staying, right? So you don't have to do that, but I mean, it's just for me to find a better way forward. And I've had to look for a lot of ways, backdoors in doing sort of things because of issues like this. So I've copied this. I'm going to go to the notepad we copied this to. So I'm just gonna bring this up. So I'm going to replace the key with the new one that I just generated, and I can add verbosity to be 5 so I can see what is happening. So I can copy this and go back to master node 2 and then run this again. Oh, let's see what happens again. Okay, I think I need to run this as a privileged user. Okay, I believe that the images are now being downloaded. Something is failing here. So I see. Okay, this node has joined the cluster and a new protocol and a new control plane instance was created. Alright, so that's good. All the errors we were seeing there was because at that point when it was initializing, it must have had some metadata being saved. So I'm going to run this command, right, so that I can run kubectl get nodes. So I believe it should still be in a non-ready state. Oh, it's ready. That's fast. Yeah, because why I said that was because the Calico ports also needs to be created here on this master node, right? Every Calico component has to be created here, and the Kubernetes ports as well. So if I do kubectl get ports, oops, I need to do all namespaces. So you can see that the ports have increased. So there are some number of ports running on master node 1 and some running on master node 2. Of course, Calico will be on master node 1 and master node 2, right? And yeah, so you can see that all ports, okay, this is still creating, port here is still initializing. Okay, I see that. Because I was wondering that it's fast. Well, this port is still initializing. So what we're going to do next is to, okay, so all ports are running now. That's fine. So we have the API server for node 1, another one for node 2, Calico systems for node 1, Calico systems for node 2, Q systems, just like that. And the Q system, this is for node 1 and node 2. So like I mentioned that I've already bound some images and copied them to the worker nodes. So we can now join the worker nodes to the cluster too as well. So I'm going to I'm going to put a verbosity of 5 here. So to join the worker nodes, so I'm just going to copy this command and then bring up worker node 1, right? So I bundled them and I just confirmed here. Let me try and expand this. So I just tried to confirm if the worker node, if the images I bundled are here. So I'm just going to slam the command here on worker node 1 and do enter. Right. Apparently it was fast and okay, error. I need to run this as a sudo user. Let me clear the screen and just run this as sudo user. Alright, so this is fast, and that was because, like I said, I copied it, right? And if I go to master node 1 or master node 2, because if I actually run kubectl command here, it's not going to work. Kubectl get nodes. So I need to go to master node 1. There is a way I can actually do it to make it work, but come on. I would even prefer to run all these commands on the master nodes. So if I do kubectl get ports, or get nodes, let's start with get nodes. Get nodes. Alright, so you can see that worker node 1 is ready. And if I try to get all the containers, so all the containers are ready as well. And you will see that the containers, the ports rather, would have increased, right? Because there are some ports that would also be running on the worker node 1, right? So now we have we need to also run this command on worker node 2 to be able to join that to the cluster. So I can just go to worker node 2 and slam in this command, do enter. Again, I have to run this as a sudo user. So I can just do sudo. And now I've been able to also join worker node 2. So you see what I did? Thank God I had to just look for a way to bundle and package all those images and put them in here. Else I would have waited for another 3 or 4 hours for those images to get downloaded. So I can go to either master node 1 or master node 2 to run the commands and confirm that I have all the nodes that are joined to the cluster. So kubectl get nodes. So you can now see that we now have the worker node 2 being joined to the cluster, and age is 37 seconds. So I have master node, 2 master nodes and 2 worker nodes here on the cluster. And then if I do kubectl get ports in all namespaces, you can see that I now have another additional number of ports running. So the more you had your master nodes or worker nodes, the more you have additional ports running in all namespaces, right? So like I said, I'm going to be posting the link to the website in the description box below. I explained a lot of things there. It's good to go over it and understand what I've explained in there. Like I explained in details and broke everything components you're installing. And also in part 2, we're going to automate this process like I mentioned. So I want to say thank you for watching. Yeah, it took me a lot. I was very patient for me to be able to do this video, especially with my bad internet. So I would appreciate if you can subscribe, like, share, and comment. It's gonna go a long way for me. Thank you once more, everyone, and bye for now.